एवरीवन। आज का क्वेश्चन अपना लीड को 3510 जिसमें हमें क्या करना है कि एक अरे दे रखा है नम्स एंड हमें एडजेसेंट पेयर सेलेक्ट करने हैं जिनका सम क्या हो मिनिमम हो एंड सपोज इफ देयर आर मल्टीपल पेयर्स possible, then we have to select the leftmost one and then we have to replace that pair with the sum of those two elements, and we have to do a minimum number of operations to make the array as non-decreasing. So the constraints given are here is the array length can be up to 10 ki power 5 and array element can be from minus 10 ki power 9 to up to 10 ki power 9. So basically it is a hard question, so make sure to be patient and watch the video up to the last to get it clearly. So if you'll see the brute force approach, so what can we do is first of all we will check whether the array is non-decreasing or not. So if it is non-decreasing, then we get our answer, but if it is not non-decreasing, then what we have to do, we have to find the pair with the minimum sum and then we have to merge both the elements as one, and we have to keep doing these until the array become non-decreasing or only one element is left. So if we'll talk about time complexity of this force approach, then the total number of elements are n, and to check the array whether it is non-decreasing, it will take big of n time, and when we have to do the sum of pair and merge, that also take big of n time, because when we merge and remove the element, we have to shift all the next elements in the array, so that also takes big of n time, and so overall time complexity is big of n square. But what we have seen here is n can be up to 10 ki power 5, so this will be giving us time limit exceed, as for 10 ki power 5 the maximum time complexity allowed is big of n log n. So next thing is, how can we optimize this solution? So as we have seen in the brute force approach, every time when we have to find a pair with minimum sum, we have to iterate through the whole array, so that is taking big of n time. So instead of using like iterating over the whole array, what we can do is we can use a min heap or priority queue. In that we store the sum and the index of the that, like what we call the pair. So in priority queue, insertion take big of log n time and finding minimum sum, so as it is a min heap, so every time it will be returning as the minimum sum, so it will be taking big of one time. So what we'll store is, we'll store the sum of the pair and first index of the pair. Suppose the pair is at 3 index number 3 and 4, so we'll be storing 3 here. So so our finding of minimum pair, which was earlier taking big of n time, now can be done in big of one time once we insert all the elements. So next, what we can optimize. So as you have seen, so once we have merged the elements, we remove the elements. In the brute force approach, we have to remove the elements, so that also takes big of n time. So now how can we optimize this thing, like so what we can do is we can use a doubly linked list. So and as we know, in linked list, removal of element takes place in big of one time. So what we have to do is we just have to find the elements and then shift the pointers of its previous shift its previous and next pointers, then the element will be removed. So here also we can see that we can using doubly linked list, we can reduce the time complexity from big of n to big of 1, yani constant time. So and what next we can do is, every time we were checking that the array is non-decreasing or not, so that also taking big of n time, so we need to optimize that also. So uh, the condition for non-decreasing is that the previous element should be either smaller or equal to the next element, right? So this is the condition for non-decreasing. So if this condition is not satisfied, which means the previous element is greater than the next element, so means that is a violation of non-decreasing array. So what we can do is we will initially count all the violations in the array, and then when we merge, we will remove the old violations. suppose we merge two elements, so these we will remove all the violations that are created by these two elements, and after merging we will add new violations, right? And if the violations are zero, if the count of the violations is zero, that means that our array is non-decreasing, means all the elements are in what we can say sorted order or increasing order. So we can see that like earlier for checking whether it is what we can say it is non-decreasing or not, it was taking big of n time, but now we just have to check one variable and our work is done, so it will be also taking big of one time. And next thing, we also should know that which elements are removed. So we also use an array to store all the elements that we remove from the array. So if we'll do these four optimizations in the brute force approach, then our work is done, right? So let's see an example and try to understand how we will be sync all those four optimizations to get our optimal answer. So we are given an array that has elements 8 1 6 2 7 3. So what we can do is initially we will making a linked list from this, so doubly linked list, right? So we'll be simulating doubly linked list using two arrays. One is previous array and one is next array. So the previous array will be storing the index of the previous element, and the next array will be storing the index of the next element. So if you see, there is no previous element to 8, so we'll be storing -1. Previous of 1 is 8 and index of 8 is 1, so this way we'll be storing all the indexes in previous, and same we will be doing for next. Here 3 do not have any next element, so there is no next pointer, so we are storing -1. So this will simulate our doubly linked list. Use then what we have to do next is we will be storing all the sums of pair in the priority queue. So let's see. So देखो 8 and 1 sum is 9 and the index of the first element is 0. 617 the first index is 1. 6 to 8 index is 2. So this way we'll be storing all the pair sum in the priority queue, and it will automatically sort all those elements. And here see, we have almost like stored n pairs, and each pair will take each element in each element insertion in priority queue takes log of n time. So all insertions take n log n time. Now next thing, that we have to count the number of violations so that we can check whether the array is non-decreasing or not. So initially we will seeing all the elements. So first element is 8, so and second is 1, so 8 is greater than 1, so this is a violation of non-decreasing array, so we'll increase count by 1. Next, 1 is greater than 6, wrong, like 1 is not greater than 6. 6 is greater than 2, yes, so we'll increase violation 1 by 1. So by this way we'll be checking all the total number of violations in the array. So then what we do is, like once all these things are done, what we'll do is we'll be uh, taking the like smallest element or smallest sum from the priority queue. So here sum is 9 7 8 9 3 9 and 10. So 7 is the smallest sum, so we'll be taking this. So we get 7 comma 1. So 7 is a sum and at index 1. If we'll say 8, this 1 and 6, so we get this. And now we have to check some conditions that whether this pair has been removed or merged earlier. So for that what we'll do is, so here our index is 1, so we need to check whether so we have, as you know, we were maintaining an array removed, in which once we remove an element we will make that as true. So remove, we have to check whether the index is removed or not, or if it is not removed, then what we do is we will find the next of this index in the that like which uh, up to on which index the next pointer is pointing. So that we'll find using next of index, and then we check whether there is any next index or not. So if next index is not equal to -1, means it is definitely pointing to some element, and then also we have to check whether the next index is removed or not. And if next index is also not removed, then we have to check one more condition, and that is that the value at current index and plus the value at next index is equal to the sum we are taking here or not. So if you'll think like why we are checking this condition, so suppose the next index get merged with some element, right? Then our current pair is not what we call feasible, or like our current pair is like already changed or manipulated. So if this condition does not hold, that means that our either next index has been merged with some other element, so we can't use that pair. So if any of the above three conditions fail, then we want to be considering the current this sum current sum pair, and we will drop it and move to the next smallest sum pair, right? So see, here our index is 1, so removed of 1 gives us 0, and then removed of 1 is 0, then we will be finding the next index. So next of 1, if you'll see, next of 1 is 2, so it gives us index 2. So again we check that whether uh, 2 is removed or not. So removed of 2 is also 0, and then we will be checking the whether the value at index plus value at next index is equal to sum or not. So value at index 1 is equal to 1, value at index 2 is equal to 6, which is equal to 7, and our current sum is also 7. So this condition is holding. So means all the three conditions are satisfying. That means our condition is like our this pair is feasible, like it hasn't been manipulated earlier, or it hasn't been merged with some other element earlier, right? So let's so next what we do this, like see, we get index and next index. So for index we will be finding previous index, and for next index we will be finding next of next index, right? So previous index we can find using previous of index, as previous is storing all the indexes of the previous element, and next of next index can be find using next of next index. See, now what we have to do is, see, this pair index and next index has some violations in the array. So now before merging these two elements as one element, what we have to do is we have to remove the violations that they were creating earlier, right? So suppose here our current element is 1, next element is 6, next of next is 2, and previous index element is 8. So see, 8 is greater than 1 means one violation it has earlier created. 1 is greater than 6, no. 6 is greater than 2. So this current pair is creating two violations, so we have to remove those two violations before merging these two elements. So what we do is we will be checking whether this current index has some previous element or not, and value of previous index is greater than value of index means violation is there, and previous, if previous element is there, then we will check if violation is there or not. If violation is there, then we will reduce violation by 1 before merging. Then we will check index and next index same way, and reduce violation if it is violation is there, violation of condition of non decreasing array. Then we do same thing, like if we check that whether next index has any next element or not, and does that 2 also has some violation. See here, 6 greater than 2 means one violation is there due to the element 6, so we reduce the violation. So once we reduce all the violations, see 8 is greater than 1 means violation is there, so we reduce violation from 3 to 2. 1 is greater than 6, this is wrong. 6 is greater than 2, yeah, violation is there, so we reduce violation to 1. After once we reduce all the violations created due to this pair, what we do is we now merge the current pair. So our current pair is 1 comma 6. So after merging we get 7. So what we do is we will store that value at the current index, yani 1. So we have stored it here, so it has become 7. Now what we have to do is we have to remove the element 6 from the our what you call doubly linked list, right? So So to remove the element, what we do is we will mark this index, that is the next index, as removed, that we have removed 2, that is 6. So we have already removed 2. Now after marking, what we have to do is we have to update the our doubly linked list also. So for updating doubly linked list, we have to shift the previous and next pointers. So see here, to remove this element, what we will do is we will update the next of 7 to 2. We will point next of 7 to 2 and previous of 2 to 7. So this part has been removed. So now our linked list has become 8 7 2 7 3. 6 has been removed. So see, we have updated our next and previous here. So see, next of 7 here, next of 7 is pointing at index 0 1 2 3, at pointing index 3. Previous of 2, that is this previous of 2 is pointing at index 1. So we have removed the element 6 by updating next and previous. Then see, after merging, what we get? 8 7 2 7 3. So we get a new element. So we have to check whether this new element is creating any violation in the non-decreasing array. So we have to add those violations. So see, 8 is greater than 7. Yeah, violation is there, because violation is there. So we will increase violation by 1. So our violation was 1 here, right? 1 here. So we will increase it to 2. Then 7 is greater than 2. Again one more violation. So we will update once again the violation. And then uh, what we have to do is we have to push the new pairs that has been formed, that is 8 7 and 7 2. We will be pushing that to our min heap or priority queue. So 8 plus 7 at index number 0. So we will be pushing 15 comma 0, and 7 plus 2 is 9 comma 1. So 9 comma 1 we will be pushing. So after iteration 1, our PQ so priority queue will be looking like this. At index 9 we will be getting some 0 8 2. These were earlier there, and we have added these two new pairs. Our violations is still 3, and we have removed the element at index uh, 2. And our previous has been shifted for element number 4, and next has been shifted for element number 2, and our linked list is appearing like this. So see, in next iteration, what we do is we again find the element with the smallest sum, that is this element 8 comma 2. So our sum is 8 and index is equal to 2. And when we check removed of 2, see here, removed of 2 0 1 2. So this index has already been removed, means it is already merged. So we will do nothing, we will remove this 8 comma 2 from the priority queue, and then again do the same thing. So see here, first condition out of those three condition has failed. So we'll be moving to the next iteration, we will not do the further steps. Again here, see, again our priority queue has become this. So 9 comma 0 is the smallest. See here, 9 in 9 9, but second one is we have to take the leftmost. So 9 comma 0, and removed of 0 is 0 only. So what we do is we will find next of 0. Next of 0 is 1, and removed of 1 is equal to 0. So no issue. Then first two conditions are satisfied, there is no issue in that. Then what we do is value at 0 plus value at 1 is equal to sum or not. So 8 plus 7, 8 plus 7 is 15, but our current sum is 9. So this condition is not holding. Why? Because here earlier 1 was there, and we have merged 1 and 6 and make 7. That means in our current pair, one of the element has already been merged. So we won't be like merging it again. We have to drop the current pair, this pair. So we'll be dropping this pair. In iteration 4, our priority queue is appearing like this. Still the number of violations is 3. Removed element is 2, this is a previous and this is next, and our priority queue is still looking like it. So if we'll see in priority queue, it will be returning us 9 comma 1. So sum is 9, index is 1. Then we check whether the index 1 has already been removed or not. No, it's not removed. We will then find the next pointer of the index element 1, that is next of 1 is 3, and removed of 3 is still 0, and value at 1 plus value at next, value at current index plus value at next index, that is 7 plus 2 is equal to sum. So 7 plus 2 is equal to current sum, means it is a valid pair. It is a valid pair as are both the indexes are intact and the sum is also maintained. So now what we have to do, we have to remove the old violation. So 8 is greater than 7, violation is there, so we reduce it by 1. 7 is greater than 2, yeah, violation is there, we reduce it by 1. 2 is greater than 7, wrong, so we reduce the violations, and after that we will be merging 7 and 2. So after merging it has become 8, 9, 2, 7 and 3, and we have to remove the next element. And then see, mark, what we do is we'll mark the next element as removed. See, we have removed the 2, and the index of 2 in the initial matrix was 3. So what we do is we marked removed of 3 as 1, means in the initial array element 3 has been removed, and after removing it we have to shift the pointers. So initially in the beginning, if you have noticed, our linked list was like this: 8 7 6 2 7 3. In the first iteration we have removed 6, and now in this current iteration our ignore 6, our linked list was 8 7 2 7 3, but now we are removing 7 as we have merged 7 and 2 at as 9, so we are removing 2. So our linked list now has become 8973. Now we will check what are the new violations created due to this merge. So 8 is 9, 8 is greater than 9, no, no violation. 9 is greater than 7, yes, so a violation is there, so we'll increase it by 1 and add the new pair, that is 8 comma 9 at and 9 comma 7. At iteration 5 what we get is, this is our priority queue, number of violations is 2, and we have removed elements at index 2 and 3, and we have updated the pointers, and our linked list is 8973. So this way we will be keep doing until our violations do not become 0, and once our violations become 0, that means we have get our array as non decreasing. So let's see the code part. So in the code part we have declared a value array to store the sum, merged sum. So here we will be using long as nums can be from minus 10 ki power 9 to 10 ki power 9, so their sum can be in the range of long. Then we will be using two arrays, previous and now next, to simulate the doubly linked list, and another array removed to check whether any element has been removed from the linked list or not. So first of all we will be building our doubly linked list. So at any point we will be storing our previous pointer and next pointer, and if there is no next, then we will be storing -1, and then we will be storing all the sum and left index pair in the priority queue. So this is a min heap, or we can say minimum priority queue. It will always return as the minimum element with minimum sum, and then we will check the number of violations or number of decreasing pairs. Okay, so once we get this, if our violations is 0 initially, that means the our array is already in non-decreasing order, so we can return the number of operations as 0 directly. Else what we do is we declare the number of operations is equal to 0, and we will be using a loop that will be working until the number of violations do not become 0. So we will be taking the top element, that is the element having the minimum sum from the priority queue, and then check whether the index u is denoting the index, whether that index is removed or not. If it is removed, it will return true. Then we won't be doing any of the further steps. We'll directly take the next element from the priority queue. But if it is not removed, then we will be checking the next element of the pair. So we'll be taking next of u, and if it, then we check whether there is any next or not. If there is no next, then it will return -1. And also we have to check whether the next element is removed or not. If next element is there and it is not removed, then we will move ahead, else we'll stop here, again take the next some pair from the priority queue. So if it is not removed, then what we will check, whether the values at index and next index sum is equal to the sum we have already stored. So if it is not equal, that means we have merged the next index with some other element. So we have to we do not consider that pair, so we have to again go back. We won't be doing further steps. Once all these three conditions are checked, that means the current pair is not touched or not merged. In that case, what we do is we will removing old violations due to this two elements. So we'll be checking these three conditions and remove the violations. Once we removed the old violations, what we will do is we will merge the elements at index u and next index v. So after merging, what we will do is we will remove the next index element, that is v, mark it as true, and we will update the pointers in the linked list. This is what we are doing. And once we have so this is repeating. So once we have merged these two, we'll add new violations that has been created due to the merging. So we'll increase our bad pointers, what we call bad counts, and push the new pairs that we get in our priority queue and increase the operation count by 1. And once our bad is 0, that is the number of violations becomes 0, then we return the total number of operations. So this is it. uh, Thank you for watching the video. I hope I was able to understand you each and everything. And if you liked it, please make sure to subscribe the channel and share this video with your friends. Thank you.